Drawing organic molecules. Because organic molecules often contain many atoms, we need shorthand methods to simplify their structures. And the two main types of shorthand representations used for organic compounds are condensed structures and skeletal structures. So let's talk about condensed first. Here I'm going to write down first an expanded structure. This is here is a compound, and I'm writing it in the expanded form. This is also known as the structural formula, and we're going to learn how to write down this in the condensed form. Um, and let me correct this because these bonds should not be so it's a bond between carbon and hydrogen, just to clarify here. All right, now here, so the rule number 1 is bond lines are omitted when you're writing the condensed structures. So that means we're not gonna make these bonds. If you can see these bonds, we're not gonna make these bonds. If there are any heteroatoms, remember heteroatoms are atoms other than carbon and hydrogen. If there are any heteroatoms present in the structure, then you do not put lone pairs on that. A carbon bonded to 3 hydrogens becomes CH3. So if you look at this carbon, it is bonded to 3 hydrogens. So we're going to write it down, CH3. Remember, we omit the bonds. We do not write down bonds. A carbon bonded to 2 hydrogens becomes CH2. So this carbon is bonded to 2 hydrogens, CH2. This one will be CH2. This one is CH2. This one is CH2. This one is CH2. And this one will be CH3. This is the condensed structure, and we can further simplify it. How can we further simplify it? Here you write down CH3, then there are 1, 2, 3, 4, 5 CH2s. So then we can write it down. CH2, put parentheses and put 5, which means that 5 CH2 groups are bonded together, and then CH3. So here I'm going to write down one more time, CH3, CH2, 5, CH3. So that's the condensed structure of this compound. Let's take some more examples for condensed structures. Example. So the first one is, if you look at this CH, there are 3 hydrogens attached with this carbon, so it is CH3. Then this one here, this carbon is attached to only 1 hydrogen, so we're going to write down CH. This carbon, the next one, it is attached to 2 hydrogens, CH2, and this carbon is CH3. Now here, going back to this carbon, we have one more C attached here, CH3. So here we have one more CH3. And remember, I said we don't put bonds, but I'm writing it right now so that I can show you the next step. This is not the final structure. Now if you look at this carbon, with this carbon we have two same groups attached, CH3 and CH3. So what we can do, we write down CH3, put in parentheses, and then say CH, CH2, CH3 means these two CH3 groups are bonded to the same carbon. So that's the final structure. Next example, start from the left and proceed to the right, and making sure that each carbon has 4 bonds. So here this carbon attached with 3 hydrogens, it is CH3. Then the next carbon, CH2 here, and then remember we said that we do not write lone pairs on the heteroatoms in the condensed structure, so omit lone pairs on the heteroatoms. So oxygen and chlorine in this compound are heteroatoms, so O. Then next is CH2 and Cl. So that will be the condensed structure. The next shorthand representation that we're going to discuss is the skeletal structures. And skeletal structures are used for organic compounds containing both rings and chains of atoms. The 3 important rules are: assume there is a carbon atom at the junction of any 2 lines or at the end of any line. And second rule is assume there are enough hydrogens around each carbon to give it 4 bonds. Draw in all the heteroatoms and the hydrogens directly bonded to the heteroatoms. So let's say, for example, first look at this compound. We're going to just assume there is carbon atom at the junction of these 2 lines. So how many carbons are there in this? 1, 2, 3, 4, 5. So put 5 points and join them. 1, 2, 3, 4, 5. These 5 points at the junction, or the points at the junction of any 2 lines, these points, or at the end of any line, these points represent carbon. And then we do not put hydrogens attached to the carbon. So if, for example, the very first carbon here on the left side, if it is attached to one other carbon, then we're going to assume that there are 3 hydrogens attached with carbon number 1, because carbon makes 4 bonds. If you look at carbon number 2 here, then it is attached to 2 carbons. That means this carbon must have 2 hydrogens again to make it 4 bonds. Now when it, so this is the skeletal structure. This is the skeletal structure of this compound. Let's draw the skeletal structure of this compound here. Again, look at carbon number 1, carbon 2, carbon 3. I'm going to represent them with the points here. So these 3 points represent these 3 carbons, and we do not put hydrogens. But if we have any heteroatom, we have to write that down. So this carbon here is attached to an heteroatom, chlorine. So we have to put that chlorine here. And if chlorine will be attached to any hydrogen, we do have to put that too, but we do not have any hydrogen attached to chlorine. And we do not put lone pairs present on the heteroatoms. So this one will be the skeletal structure of this compound.
Made with Doodlecast Pro.